This is the 2022 AMC 10A problem 24 and 12A problem 24. How many strings of length 5 formed from the digits 0, 1, 2, 3, 4 are there such that for each j in 1, 2, 3, and 4, at least j of the digits are less than j? For example, 0, 2, 2, 1, 4 satisfies this condition because it contains at least one digit less than 1, 2 digits less than 2, 3 digits less than 3, and 4 digits less than 4. The string 2, 3, 4, or 4 does not satisfy the condition because it does not contain at least 2 digits less than 2. All right. So this problem is a classic example of complementary counting. It is very difficult to count the number of ways to satisfy the condition, but to count the number of ways that don't satisfy the condition is much easier, especially if we look at it on a case-by-case basis. For example, how many ways are there for us to violate this condition? How many ways are there for it to not contain at least one digit less than 1? Well, that happens whenever there isn't a 0, right? So let's count the total number of cases. The total number of ways to pick 5 digits in a 5-digit string is 5 to the power of 5, right? But we can subtract off the number of ways that we violate this condition. And the number of ways we do that is the number of ways for us to choose all 5 digits to not be 0. All 5 of them aren't 0, then it violates that condition. And of course, the number of ways to do that is just 4 to the power of 5. All right. So now we've subtracted all the ways for this to not be true. So now we're just left with all the cases where there is at least one digit less than 1. Okay. Out of all those cases, how many cases are there where we don't follow this condition? Well, if we don't follow that condition, right, but we do follow the first condition, because now we only have numbers that follow the first condition. So there has to be at least 1 0 somewhere, but then the other 4 digits all have to be 2, 3, 4. So basically, one of the digits has to be a 0, and the other 4 have to be the numbers 2, 3, or 4. And the reason for that is, of course, if another one of them was a 0 or a 1, then that would make the condition true. And we're trying to violate the condition. So how many ways are there to pick a string with 1 0 and 4 numbers, the other 4 numbers in the string, 2 through 4? Well, that's simple. We pick one of the 5 spaces to have the 0, and then among the other 4 spaces, that's just 3 to the power of 4. 3 times 3 times 3 times 3. Because for each of the other 4 spots, we have 3 choices. All right, so now we've counted out all the numbers. We've counted out all the strings that violate the second condition. So now we only have strings left that agree with the first and agree with the second. Okay, out of all those strings, how many are there that violate the third? Well, we have to have 2 digits that are either 0 or 1. And we have to have the other 3 digits to be among 3 or 4. Right? The reason for this is obvious, right? We need to have 2 digits less than 2, but also we can't have 3 digits less than 3. Okay, well, how many ways are there to do this? Well, we just have to choose the 2 spots where we have 0 and 1, right? And that chooses the 3 spots where we have 3 or 4 in the process, which is 5 choose 2, which is 10 ways. And then we multiply by the number of ways to choose 0 or 1 for those 2, which is 2 squared, right? Times 3 cubed. No, 3 squared. 3 squared, because it's 3 times 3. Oh, no, it is 2 cubed. My bad. 2 cubed. 2 cubed, because for each of the 3 slots is 2. So it's 2 times 2 times 2. However, this isn't true, because remember, if we have 1 and 1, for example, as those 2 digits, then we aren't agreeing with this condition anymore. So we have to have at least 1 digit less than 1 and at least 2 digits less than 2 with these 2 digits. So we have to have either 0, 0, 0, 1, or 1, 0. 1, 1 doesn't work here. So this is actually not 2 squared. This is not 4. This is 3. So that's an important thing to note. All right. So now we are only left with strings that satisfy these first 3 conditions. How many ways are there for us to make the fourth condition violated? Well, we have to have 3 digits be among 0, 1, or 2, right? In order to satisfy those conditions. And then the other 2 digits have to be 4. Okay, so there are 10 ways for us to pick which 2 digits out of the 5 are going to be 4s. And then it's just a matter of picking the string of 3 numbers. But remember, as we mentioned before, this is not as simple as 3 cute. This is not as simple as 3 cute. And the reason for that is that we need to have it agree with all 3 conditions, right? By choosing numbers 0, 1, and 2, like among those 3, all we're doing is guaranteeing that this condition is met. But for example, this condition could not be met, or this condition could not be met, right? So we have to make sure that we have at least 1 0 from it. And we have to make sure that after including that 1 0, we have to have another number that's a 0 or a 1. So we actually have to start another parentheses here in order to count the number of ways to have a string of 3. Right? We have to figure out the number of ways to have a string of 3 that agrees with the first 3 conditions. Okay, so there are 27 ways total, and we can just subtract. This is almost like we're doing this again. We're doing this again, but it's in a simpler way. Because now we're doing the same kind of problem, except it's only a string of length 3 that meets these 3 conditions. So it's almost like we're doing the problem again within itself, but a smaller version of the problem. So 27 ways to pick the string, but then how many ways are there for us to violate the first condition? Well, that's just 8, because each of the numbers is only 1 or 2 instead of 0. We have no zeros, right? But how many ways are there for us to violate the second condition? The only ways for us to do that are to have 0, 2, and 2. There's no other way to do it, because we have to have at least 1 0, and the other 2 numbers can't be less than 2. So they have to be 2, 0, 2, 2. So there are 3 ways to arrange the numbers like that. And bam, this is it. This is what we get right here. And if we go through this, we get 3,125 minus 1,024 minus 405 minus 240 minus 160. And our answer is E.